Hey everyone, today we are going to be talking about how many times greater one number is from another number in scientific notation. How many times greater? Anytime you're dealing with scientific notation, because the numbers look different, our minds sometimes don't know whether we should add, subtract, multiply, divide. So one strategy that I use often with scientific notation is putting it in simpler numbers first, and then I can see if it is adding, subtracting, multiplying, dividing. So we're going to start with some easy numbers. How many times greater or larger is 36 than 12? With those numbers, I can see to figure it out, and it might be intuitive to you. You might not even have to write it down, but I do 36 divided by 12 is 3. So it is 3 times greater. Again, it might be intuitive to you, number 2, that 500 is 5 times greater than 100. So you're dividing the larger number by the smaller number. 9 is how many times greater than 6? Well, 6 goes into 9 one time with 3 left over. So 1 and 3, 6. So 9 is 1.5 times greater. And 7.2, how many times greater is 7.2 than 0.6? Again, I can set it up as a quotient or a division problem. 7.2 divided by 0.6. And then I will write it over here. 7.2 divided by 0.6. We move the decimal place once in both places. 6 goes into 7 one time. With 1 left over, bring down the 2. 6 goes into 12 2 times. So 7.2 is 12 times greater. So it's all about dividing in this one. So again, our lesson for today, our I can statement, I can determine how many times bigger a number is using scientific notation. So on this page, it just tells you exactly what we just did. How many times greater is the diameter of the sun than the diameter of the earth? So the diameter of the sun is the greater of the two numbers, and we can tell that by the exponent. So we've already practiced that skill. So you set it up with the larger number on the top, the smaller on the bottom. You divide the numbers. You divide the powers of 10 by subtracting the exponents. And then make sure that this time we want it in standard form, not scientific notation. And we're going to round. So the diameter of the sun is about 109 times greater than the diameter of Earth. So let's try a practice problem. How many times greater is the thickness of the dime than the thickness of the dollar bill? Well, I'm going to first look at my decimals to see which one is larger. So we know that the thickness of a dime is greater because this number is greater. So we're going to put this on the top, 1.4 times 10 to the negative 1 over 1.1 times 10 to the negative 2. And then we're going to do some dividing. So when I divided, I came up with 1.28, etc., etc. So I am going to just round to 1.3 times 10 to the, and then remember when we are dividing powers with the same base, we subtract. So negative 1 minus negative 2, so keep, change, and that's a 1. So we have to multiply 1.3 times 10 to the first, and we want it in standard form, so we have to move this over. So a dime is about, because we rounded, about 13 times greater than the thickness of a dollar bill. So on your assignment today, most of your problems, first ask which one is greater. That forces you to really think which one is going to be at the top, because the greater one goes on the top, and then do the division. So the distance from the sun to Mars is 2.2 times 10 to the 8th, where the sun to Venus is 1.1 times 10 to the 8th. Since they're both 10 to the 8th, we have to then go to the decimal and look. 2.2 is greater than 1.1, so the sun to Mars is greater. How many times? This is where we have to set up our division problem. My stylus just doesn't want to work. 10 to the 8th times. So I'm going to do this part first. 1.1 goes into 2.2 two times 10 to the, and when we're dividing powers of the same base, we subtract. That gets me 0. Anything to the 0 number is 1, so it's like you're saying 2 times 1. So how many times greater? 2 times greater. We out.